Hi everyone, I'm Brock. So today let's start review some academic paper, especially in AI area. So my plan is to read one academic paper a week and 50 academic paper in 1 year. At this moment, I made a plan for 12 years if I can. So yeah, so my goal if everything happened as my expectation, I should read 600 academic papers in ARL in the following 12 years. So my plan is to every weekend, after I read this paper, I will use AI to generate a report, which somehow may help me to understand what this paper is all about. So yeah, so let's start. So the paper I want to read today is called Attention is all you need. So this is the original paper. It's not very long, but it's very important this is published in December 2017. And this is very important for this round of AI golden rush. So what is Transformer? Transformer is a novel neural network architecture designed specifically for sequence-to-sequence tasks, such as machine translation and text summarization. Its most distinctive feature is that it completely abandons traditional recurrent neural networks, RNN, and convolutional neural networks, CN, relying solely on the attention mechanism to process data. So this is how the workflow looks like. Core function explained. Number one, parallelized processing. Traditional RNN must process each word sequentially, like people waiting a single queue, while the next person cannot move until the previous one finishes. In contrast, the transformer can process all words in a sentence simultaneously, like having multiple service windows open at once, dramatically improving efficiency. Here's an example. RNN approach to translate the sentence, I love learning machine learning. The RNN must process I, then love, then learning, one after another, requiring 5 sequential steps. But for transformer approach, the transformer can see all 5 words simultaneously and analyze their relationships in parallel, understanding the entire sentence in just one step. Oh, interesting. Number 2, self-attention mechanism. The self-attention mechanism allows the model to understand the relationship between each word and all other words in a sentence. This is similar to how your brain automatically associates contextual information when reading to understanding the meaning of each word. Suppose we have the sentence, the cat ate the fish because it was hungry. When process the word eat, the human brain automatically knows it refers to the cat rather than the fish. The transformer's self-attention mechanism can also learn this association. establishing a strong connection between it and the cat, while the connection to fish is weaker. Number 3, multi-head attention. Multi-head attention is like understanding the same thing from multiple perspectives. The paper uses 8 heads, where each head can learn to focus on different types of relationships. Imagine you are reviewing a painting. Head 1 focus on color combination. Head 2 focus on compositional layout. Head 3 focus on lighting and shadow effects. Head 4 focus on brushstroke details and so on. Each head analyzes the painting from a different angle, and by combining all heads' observations, you gain a comprehensive understanding of the artwork. All technologies, skilled dot product attention. Q is query. K is key. V is value. D sub k is dimension of key vector. Root square D sub k. So attention of qk, V equals softmax of qk transpose. Qk transpose divided by square root of dk times V. Imagine you are searching for a book in a library. Query is you want to find a book about machine learning. This is your question. Key is each book's title and keywords. This is the book's index information. Value is the actual content of the book. This is the knowledge you ultimately want to acquire. Dot product calculates the relevance between your needs and each book. Which book best match your needs? Scaling prevents relevance scores from becoming too large, making score more reasonable. Softmax convert relevance score into a probabilities distribution, determine which books to focus on. Multiply by V, obtain content weighted by relevance, extract knowledge from the most relevant books. Y divided by D sub k. When the dimension D sub k is large, 16 in the paper, the dot product results become very large. This is like an exam, where if there are too many questions, the total score will be too high, leading to excessive score differences. Dividing by root square D sub k normalizes this score, allowing the softmax function to work better and avoiding gradient vanishing problems. Here it mentioned gradient vanishing problems. There it should explain to me what is gradient vanishing problem, right? Because I may have no background about what is this. So calculation is D sub k is 64. So root square will be 8, means the dot product result is divided by 8 to keep values in a reasonable range. Positioning encoding. Since the transformer doesn't process sequentially like RNN, it needs a way to understand the word position information. Use sine and cosine functions to encode position information. Pose. So when you explain the symbols, you should also explain in English as well, right? Rather than just provide the Chinese explanation here. Pose is position in sequence. I is dimension index. D submodel is model dimension. 2i is sine. 2i plus 1 is cosine. So it will be PE at position pose and the dimension 2i equals sine and position divided by 10,000 to the power of 2i over d mod. Imagine a clock, hour hand, rotate slowly representing low frequency information, long range dependency. Minute hand, rotate at medial speed representing medial frequency information. Second hand, rotate quickly representing high frequency information, short range dependencies. Positional encoding user use sine waves of different frequency, like using multiple pointers rotating at different speeds to mark positions. Allowing the model to capture both short-term and long-term positional relationships simultaneously. Item 3, rise into connection and layer normalization. Residual connection. It's like adding new knowledge to existing knowledge, rather than completely replacing it. This is similar to when you learn new content. You don't forget what you learned before, but supplement it with the original foundation. This design helps avoid gradient vanishing problems in deep networks. So this example should also provide an English explanation here. AI ML terminology. RNN, recurrent neural network. A neural network that processes sequential data by maintaining an internal hidden state. That is updated at each time step. LSTM, non-short-term memory. A type of RNN designed to better capture long-range dependency by using gating mechanism. CNN. Convolutional neural network. A neural network that uses convolution operations, commonly used for image processing, BLEU, bilingual evolution, and starting. A metric for evaluating the quality of machine-translated text by comparing it to reference translators. FFN, feed-forward network, a neural network where information flows in one direction from input to output without loops. BPE, backpire encoding, a data compression technique used to tokenization that iteratively merge the most frequent pairs of characters. WMT, Workshop on Machine Translation, an annual conference focused on machine translation research and evaluation. Important concepts. Attention mechanism, a mechanism that allows a model to focus on different parts of input when producing each part of the output, mimicking human selective attention. When translating the cat that on the mat to French, the attention mechanism helps the model focus on cat when generating chat. And on mat when generating tapas. Tapas. Number 2, encoder-decoder architecture. A neural network architecture consisting of 2 components: an encoder that processes input into a compressed representation, and a decoder that generates the output from this representation. Like translation work, encoder means understand the original text's meaning, extracts the call, express this information in the target language. Self-attention. An attention mechanism where the query, key, and value all comes from the same sequence, allowing the model to relate different positions within a single sequence. In the sentence, the animal didn't cross the street because it was too tired. Self-attention helps the model understand that it refers to animal, not street. Masking, a technique used in the decoder to prevent the positions from attending to subsequent positions, ensuring that predictions for position I can only depend on load outputs as positions less than I. Like not being able to look at answers ahead during an exam. The model cannot pick the future worlds when generating the current world. System design and architecture. The transformer adopts a classical encode-decoder architecture, but unlike traditional architectures, it's entirely based on attention mechanism. Encoder nail system. Each encoder nail contains two main sublayers: multi-head self-attention layer, position-wise feed-forward network. Decoder nail system structure. Each decoder nail constraints contains three main sublayers: masked multi-head self-attention layer, encoder-decoder attention layer, position-wise feed-forward network. Masked multi-head self-attention layer, encoder-decoder attention layer, position-wise feed-forward network. Key parameter configuration. Layers. Six layers, each for encoder and decoder. Model dimension. Dimension of embedding and hidden layers. Forward feed network dimension. Inner dimension of FFN. Attention heads. Number of attention heads. Dimension per head. Calculate as D submodel divided by H. Dropout rate. Regularization parameter. Total parameters. Median. Forward network explained. X is input vector. W1, the weights for first layer. B1, the bias vector for first layer. Max, ReLU activation function. W2, the weights for the second matrix. B2, the bias vector for the second layer. So it's FFN of X equals max of 0 and XW1 plus B1 times W2 plus B2. So the processing flow is input, then linear expand, renew. You should explain what is renew activation function, right? Linear 2, compress. So the feed-forward network is like an information compression and a refinement process. First, expand to higher dimension, like opening a book to reveal model details. Use IIU to filter useful information, like removing useless details. Then, compress back to original dimensions, like summarizing the essence into a book. Workflow pipeline. Translating English to German, like as an example. The cat is on the mat. So you see, actually here you should use Chinese as an example, right? Rather than German. So the input sequence will input the cat is on the mat. The encoder will do a 6-layer encoding. Then context vectors will do the memory. And then it provides context to decoder. So alt-regressive, regressive generation. Then it will generate output the content and translation completed. Okay. So step 1, tokenization. Step 2, embedding. Step 3, position encoding. Step 4, encoding processing. Step 5, decode generation. So major milestone. So 2018, initial attention from AI research community. 2019, BERT and GPT drive citation growth. 2020, GPT-3 released, citation explosion. 2022, ChatGPT attracts global attention. 2023, became one of the most cited AI papers. Comparison review. Academic average. A typical AI paper receives about 10 to 50 citations. Attention is all you need. Currently exceeds 100,000 citations, qualifying as a super milestone paper. Okay. Reproductions, over 1,000. Implementation in various language and frameworks. And commercial applications, so many of them. Like OpenAI, so market value impact, OpenAI, Anthropic, Google, Microsoft. Founder's background. The paper has 8 equal contribution first author, all from Google. Ashish Vaswani, Google brand. Design and implement first transformer. Okay. So for Ashish Vaswani, PhD from University of South California, Korea, Google Brain to co-found Essential AI. Major achievements, core design of Transformer architecture, H index, Typical AI research has H index of 10 to 20. 40 plus is exceptionally high. Team size, 8. Main contributors listed on paper. Internal Google collaborators supporting acknowledgements, 2 people. Global research, more than 10,000. Industry practitioners, more than 100,000. That's crazy. Direct commercial value. Core tech for GPT serials. Cloud based on Transformer. Use Transformer to improve Google Translate. Use Transformer to improve the translation. GitHub Copilot, GPT-based code generation. Character.ai, founded by paper author. Oh, that's insane. Indirect commercial value, driving the Intel AI industry, estimated to create hundreds of billions in market value. Threats, new architecture competition, regulation risks, opportunities, multimodal expansion, edge deployment, vertical industry apps, weakness, high computer cost, high energy consumption, strength, revolutionary architecture, wide applications, continuous evolution. Who? Google Brain Team, 8 core authors. What? Proposed the attention-only transformer architecture. When? First released June 2017. Officially published on NIPS, December 2017. Well, Google Brain and Google Research. Why? Solve RNN parallelization issues, improve training efficiency, BERT long-range dependency modeling. Key insights, simple but effective. Transformers, the core idea of transform is so surprisingly simple. Replace recurrence with attention mechanisms. This simple change brought revolutionary results. This teaches us sometimes the simplest solution is often the best. Implementation. When designing systems, don't overcomplicate. Try the most direct approach first. Insight 2. Parallelization is key. RNN's sequential processing is its biggest bottleneck. Transformer improved training speed dozens of times through parallelization. Implication. In modern computing, the ability to parallelize often determines the performance ceilings. Insight 3. Universality of attention. Attention mechanisms apply not only to NLP, but have been successfully used in computer vision. Vision transformer, VIT. Speech recognition, speech transformer. Protein structure prediction, AlphaFold 2. Reinforced learning, decision transformer. Implication. Good foundation architectures have cross-domain university. Strategic insights, power of open source. Google chose to open source Transformer, enabling global research to innovate upon it, ultimately forming a massive ecosystem. Implication. Open source can establish technical standards and create network effects. Insight 5. Long-term value of foundation research. Transformer was initially designed just to improve machine translation, but ultimately gave rise to revolutionary applications like ChatGPT implementation. The value of foundation research may take years to manifest, but when it does, it's exploration. Philosophy insights. The paper title is not just a technical state, but a philosophy idea. Focus on what matters most. In massive amounts of information, learning what to attend is a key. This applies not to AI, but also to life. For AI, no need to remember everything, just know what to attend to when. For life, focus on what's important, ignore noise. Yeah, so here's some suggestions on must-read papers. And here are some tools and frameworks. And some YouTube channel. Yeah, I guess that I can. Okay, maybe I can give it a try. Stack Quest with John Stammer. 3 blue, 1 brown. Yeah, subscribed. And Andre Capathy. Okay, subscribed. Yannick Hilcher. Actually, okay, subscribed. Actually, I'm not sure. I will read this book. I will watch YouTube videos, but I guess that based on what I subscribed, I think one of the reason why I want to subscribe those YouTubers is that it may influence how YouTube recommendation algorithm works for me. 2 minutes paper. Subscribed. Deep learning.ai. Lex Friedman. Subscribed. AI coffee break with Latitia. Subscribed. Machine learning street talk. Subscribed. Okay, cool. So yeah, so I think that I subscribe all 9 YouTube channels. Here's some Chinese model. Here's some evaluation benchmarks. Some online courses. Some books. Okay. And here's some mathematical formulas. I think one of the good things is that when I generate this report, it helped to visualize this the math formulas. Okay. and it also give a minimum transformer implementation. So conclusion. Attention is all you need. It's not just a technical paper, but a milestone in AI history. Its impact has transcended machine translation, become the cornerstone of modern AI. From ChatGPT to image generation, from porting folding to code generation. Transformer architecture is everywhere. This paper teaches us simple ideas when properly executed can change the world. Yeah, so I think that this, of course, we always need, to read the original paper. But I think that the report provided generated by AI can somehow as a set tool which can help us to understand it, especially through some metaphor to understand the original paper much better. So yeah, that's pretty much for this paper. Thank you. Bye.